Every object you see, your phone, your hands, even this screen, obeys rules that no human intuition was ever designed to understand. Rules so strange that even the scientists who discovered them admitted they don't make sense. One physicist explained these rules better than anyone else, not by simplifying them, but by embracing how strange they truly are. His name was Richard Feynman, and this is quantum mechanics, explained through his eyes. By the end of this video, you won't just know what quantum mechanics is. You'll understand why the universe could never behave any other way. Before the 20th century, physics seemed complete. Newton's laws explained motion. Maxwell's equations explained electricity and light. The universe looked predictable, like a perfectly built machine, but experiments started to fail. Atoms behaved strangely. Light acted like particles. Electrons refused to follow classical paths. Richard Feynman often emphasized that quantum mechanics was not invented because physicists wanted weird ideas. It was invented because nature forced them to accept them. Quantum mechanics, Feynman explained, describes how nature actually behaves, not how we wish it behaved. Feynman made one thing very clear in his lectures. The universe is not classical at a fundamental level. In classical physics, objects have exact positions. Motion follows clear paths. Causes lead directly to effects. But in the quantum world, particles don't have definite positions. They don't travel along single paths. Outcomes are governed by probabilities. Feynman famously said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." This wasn't a joke. It was a warning against forcing classical intuition onto a non-classical reality. One of Feynman's most revolutionary insights was his path integral formulation. Instead of asking, "Which path does a particle take?" Feynman asked, "What if it takes every possible path?" According to quantum mechanics, a particle explores all paths simultaneously. Each path contributes to the final outcome. Some paths reinforce each other. Others cancel out. What we observe is the sum of all possibilities. This idea explains interference patterns, diffraction, quantum tunneling, and it leads directly to the most famous experiment in physics. Feynman called the double-slit experiment the central mystery of quantum mechanics. Here's why. When particles like electrons are fired one by one at a screen with two slits, they create an interference pattern, a pattern that only waves should create. But when observed, each electron hits as a single particle. Feynman's conclusion was shocking. Electrons behave like waves when not observed, and like particles when measured, not because they decide to, but because measurement itself changes reality. In Feynman's lectures, measurement is not just observation, it is interaction. To measure a particle, you must interact with it. Interaction disturbs the system. Disturbance changes outcomes. This leads to uncertainty principle, collapse of the wave function, probabilistic predictions. Quantum mechanics doesn't predict exact results. It predicts likelihoods. And according to Feynman, that's not a weakness. That's how nature works. To understand particle interactions, Feynman introduced Feynman diagrams. They are not literal pictures. They are calculational tools. Each diagram represents possible interactions, possible paths, possible exchanges of particles. Every diagram contributes to the final probability. The universe doesn't choose one diagram. It sums all of them. This concept powers quantum electrodynamics, QED, particle accelerators, modern quantum field theory. Feynman once said QED was the most accurate theory in the history of science, and it is accurate to more than 10 decimal places. Feynman never tried to make quantum mechanics feel comfortable. He insisted, nature doesn't owe us intuition. Reality doesn't care about common sense. Mathematics describes truth better than imagination. He warned students, do not keep saying to yourself, but how can it be like that? Because you will get stuck. Quantum mechanics is not strange because it is wrong. It is strange because we evolved in a world where quantum effects average out. Feynman's ideas influence quantum computing, particle physics, nanotechnology, modern electronics. Every transistor, laser, and semiconductor obeys quantum rules. Quantum mechanics is not abstract philosophy. It is the operating system of reality. Richard Feynman didn't ask us to understand quantum mechanics emotionally. He asked us to respect it intellectually. Nature is not weird. Nature is precise. And quantum mechanics is simply the language it speaks. If this universe feels mysterious, it's because it truly is.